Okay, I would like to thank everybody for attending today. We really appreciate everyone coming down, especially at the last minute here. So I'm just going to introduce myself. My name is Paul Atkins. I'm the Marketing Communications Coordinator here for Laser Technology. Been here almost 12, actually working on 13 years in a couple months. So I'm just going to do a really brief highlight of our history. It's something that we're certainly proud of, and I'll kind of give us some street credit, we hope, with you folks. One of it, we did a special project for NASA, and they needed, basically a laser that can measure the proximity as they are docking up in to the space station. So it was very successful, and they built about 6 of them, and they were considered standard equipment on all space docking maneuver flights. We also have partnered up with Bushnell. They make we co-created the very first recreational rangefinder. So we've been in the rangefinder business quite a long time. This was actually in the early 90s, I'd say closer to 92. And we're still active today on developing Bushnell's line of recreational rangefinders. We also invented, really from the technology that was used up at NASA, because it did measure proximity as a distance and also velocity for speed. So we've taken that technology and embedded into the very first handheld speed device that competed against radar that, of course, dominated the market. And so we are responsible for the very first speed laser ever created, and are still active in this market and have certainly the most advanced technology in the world. And this is really where we got our start in the professional measurement market. We did a project actually with the U.S. Forest Service, and basically developed a unit that can measure distance, height, have a scope at the top for tree diameters. And this also had an embedded compass inside of it, so you can do offsets, which is an example here that you're seeing. So this is basically the very first reflectorless handheld total station that can integrate with GPS to do laser offsets. So we've certainly come a long way. I'll show you some advancements of where we are today with that. But thanks to the U.S. Forest Service and the consulting, we're able to develop this unit called the Original Criterion. So nowadays we actually have all of that functionality built into one small handheld pocket-sized laser. The gyroscope in the back is representing really the core of our technology, which is essentially, it's called true vector compass technology. Once calibrated, which literally takes 30 seconds in the field, you can pivot and rotate this laser to any orientation and still develop a 1-degree azimuth accuracy, which is absolutely still unheard of in anything else out there in the market today. And then this is just one of about 65 patents that we have filed that are active worldwide. So we have a bunch of US and a few international, but we certainly have a lot of patents on the laser measurement technology, and also our compass technology, and even some mapping software. So just real quick, just going into the basics of our measurement. So all of our lasers have a rangefinder inside, as well as a tilt sensor, and some have a compass that I just mentioned. So any one shot taken is going to measure that slope distance, inclination, and if it has a compass, also the azimuth. And then it will calculate your vertical distance and your horizontal distance. It also has a built-in height routine. So basically the height routine is you can shoot any point along, let's say a tree or a pole, and then it's going to calculate that horizontal distance. And then it's going to do 2 more additional shots, the top angle and base angle, and it's going to derive then to the calculation of what the height of that object is. So it's a simple 3-point height routine. Another methodology you can do for heights is actually just measuring the slope distance and inclination and getting that vertical distance calculated to the top and base angle, and therefore you can actually just mathematically in your head add those 2 numbers together to derive a height. This is actually a little bit more for objects that aren't quite completely perpendicular to the ground, so if they have a little lean to it or something, this is a preferred method. And then what else is unique is our lasers with the tilt sensor are going to be able to calculate what we call a missing line. This is a 2D missing line. So you can get slope percentages, you can get degrees of really any slope. So you just take one shot to the top and one shot to the bottom, and then ultimately it's going to calculate all these values, but the real value that you're looking for is that inclination that, again, can be displayed in degrees or percent.